However, it was pushed away from the sun by some mysterious force. And it was mysterious because there was no evidence for dust or gas that you see around comets. That the evaporation of those gives the comet a kick from the rocket effect, the same mechanism that pushes jet planes. But there was no evidence for dust. It was definitely not a comet of a type that we are familiar with.
On October 19, 2017, astronomers spotted something that would flip the script on everything we thought we knew about space. A faint blip on the Pan-STARRS telescope in Hawaii turned out to be Oumuamua, the first confirmed interstellar object ever seen passing through our solar system. But this wasn't just any space rock. It wasn't behaving like a comet. It wasn't shaped like an asteroid. And most importantly, it wasn't moving like anything we'd ever tracked before. Scientists were stunned. Some called it a comet without a tail. Others insisted it was a new kind of interstellar rock. But as the evidence piled up, a new, far more uncomfortable idea began to emerge. What if it wasn't natural at all? Now, after years of study, cutting-edge tracking, and a level of scrutiny unlike anything before, we may finally have some answers. But they're not comforting. Because everything we've learned since 2017 suggests that Oumuamua's origin and its behavior defies every natural law we rely on to understand the cosmos. The unnatural origins of Oumuamua. For 6 years, Oumuamua remained one of astronomy's biggest mysteries. Unlike traditional comets, which leave behind clouds of dust and gas, this object didn't emit anything. That's strange, because cometary material typically evaporates near stars, creating jets that act like tiny thrusters, giving them a visible tail and altering their trajectory. But Oumuamua showed none of that. No trail, no dust, no gas, just a silent, speeding anomaly. Recently, astronomers finally managed to track down its galactic origin using sophisticated models of the Milky Way's gravitational field and data from the ESA's Gaia mission. The findings? Startling. Oumuamua came from the thin galactic disk, a relatively calm and flat region where most young stars reside. But that's the first red flag. Interstellar objects are usually ejected from chaotic regions, like binary star systems or areas with giant planets, slinging debris through gravity. Oumuamua, however, was flung from a region where such violence shouldn't exist. And it gets weirder. Oumuamua isn't spinning like most tumbling space rocks. It's wobbling like a spinning top that's been violently tossed. That wobble suggests it was thrown. But again, no sign of a mechanism capable of doing that in the calm system it came from. Harvard astronomer Avi Loeb and his team were stunned. Their analysis confirmed that all potential origin stars were quiet, sun-like, with no gas giants or companions to sling this thing into space. Motion that breaks the rules. If the origin of Oumuamua was strange, its motion through space was even stranger. Objects ejected from star systems typically travel at high speeds, with random trajectories, spinning wildly like cosmic debris. But Oumuamua, it was almost perfectly still. Astronomers measured its speed relative to the local standard of rest, the average motion of stars in our region of the galaxy. The result? Zero velocity. It wasn't moving like a tossed rock. It was just sitting there. In practical terms, it was like a buoy in the ocean, floating motionless as our solar system drifted toward it. That's not how natural objects behave. Normally, comets and asteroids streak through space at high speeds from chaotic ejections. Oumuamua's behavior raised a chilling possibility. Was it placed there on purpose? Avi Loeb took it a step further, saying that if he wanted to hide an instrument in space, he'd park it exactly where Oumuamua was, in the local standard of rest, and right along the galactic midplane, where it could easily blend into the cosmic background. Now, think about that. An object ejected from a quiet star system, traveling with impossible precision, aligned perfectly along the most densely packed region of the galaxy. Statistically, the odds of all that being random are virtually zero. Some scientists remain cautious about jumping to conclusions, but others are beginning to whisper what they can no longer ignore. This might not be natural. This might be intentional. A close encounter, too precise to ignore. As Oumuamua entered our solar system, it didn't just drift by like a passive rock. Its path was alarmingly precise. In fact, it passed closer to Earth than to Mercury or Venus. Even though those planets orbit much nearer to the Sun, that's not just a fluke. Simulations of thousands of interstellar objects entering our solar system show that less than 1% would come anywhere near Earth. Yet Oumuamua did, almost directly. It's as if it was aiming for us. Now imagine this: a cosmic object traveling for millions, maybe billions of years through space. This is where the mystery deepens, because right after it passed Earth, something even stranger happened. It accelerated, without any visible force. No outgassing, no jets. Just a sudden shift in speed that shouldn't be possible for an inert object. And that raises even more disturbing possibilities. The light sail theory, technology beyond our reach. After Oumuamua passed Earth, scientists noticed something unnerving. It wasn't slowing down. In fact, it began to accelerate, even though there was no visible reason why. Normally, comets speed up because of outgassing. When sunlight heats up ice inside the comet, it vaporizes and pushes it forward like tiny thrusters. Yet, its path was clearly being altered. This contradiction baffled astronomers. How could something that looks like a rock move as if it had thrusters? That's when Harvard's Avi Loeb and his colleague Shmuel Bialy dropped a bombshell theory. What if Oumuamua was being pushed by sunlight? They proposed that Oumuamua might be a light sail. It's the same principle behind Japan's Icarus spacecraft, and the light sail 2 launched by the Planetary Society in 2019. The idea is real, the technology is real. But Oumuamua's version would be orders of magnitude more advanced than anything we've built. According to their calculations, Oumuamua would need to be an ultra-thin sheet, between 0.3 and 0.9 millimeters thick, but up to 400 meters wide. Not only is that incredibly thin, but it's also precisely the dimensions you'd expect from a designed spacecraft, not a natural object. This doesn't mean aliens are definitely involved, but it does mean that nature has never produced anything like this before. No asteroid, no comet. Nothing in our records matches this shape, behavior, or acceleration. More than one, the interstellar visitors we've missed. As unsettling as Oumuamua was, what if it wasn't the only one? In 2014, 3 years before Oumuamua's discovery, another interstellar object may have entered our solar system. Designated IM-1, it crashed into the atmosphere near Papua New Guinea. And what scientists found after the fact was shocking. The meteor had an interstellar trajectory and a material strength higher than any known meteorite in NASA's database. This discovery, made public years later, forced scientists to reconsider how rare these cosmic visitors really are. The old assumption was that interstellar objects, like Oumuamua, were once-in-a-lifetime anomalies. But IM-1 challenged that idea. What if these objects aren't rare at all? What if they're common, and we've just been blind to them? That's where the Galileo Project comes in. Founded by Avi Loeb, the project uses AI-driven telescopes to systematically search for more anomalies like Oumuamua before they escape our detection. Its mission is bold: to find interstellar objects that behave in ways nature can't explain. Early results are promising. Loeb's team believes we've probably missed countless objects over the decades simply because we weren't looking in the right way. Now that we know what to watch for, strange acceleration, odd trajectories, precise movement, scientists suspect we'll see more. The age paradox, a timeline that shouldn't exist. If Oumuamua was strange because of how it moved and where it came from, It becomes even more puzzling when you consider how old it is. Based on its galactic orbit and velocity, Loeb's team concluded that Oumuamua is shockingly young, somewhere between 1 to 2 billion years old. That may sound old by human standards, but in cosmic terms, it's a newborn. For comparison, Earth is 4.5 billion years old, and our Sun is around 4.6 billion. So Oumuamua's origin system is a cosmic infant by comparison. That raises a massive problem. If Oumuamua is natural, it should show signs of cosmic aging. Interstellar space is not kind, it's filled with radiation, particles and forces that wear down surfaces over time. But Oumuamua looks pristine, too clean, too fresh, as if it hasn't been exposed to billions of years of cosmic weathering. But here's the bigger problem. If Oumuamua is artificial, the timeline becomes almost impossible. This leads to one terrifying possibility. The intelligence behind Oumuamua didn't originate in the star system it came from. Maybe they colonized it. Maybe they passed through. But wherever this object began its journey, its creators may be much older, smarter, and far more mobile than we imagined. The Borisov comparison: nature versus mystery. If Oumuamua left scientists scratching their heads, Comet 2 I/Borisov brought some much-needed clarity, or at least contrast. Discovered in 2019, Borisov was only the second confirmed interstellar object to enter our solar system. But unlike Oumuamua, it behaved exactly as scientists expected. It had a coma, that hazy cloud of gas and dust that forms as a comet heats up near the sun. It had a tail, and its trajectory followed the rules of gravitational dynamics. It didn't wobble, accelerate mysteriously, or arrive with impossible precision. Borisov was, in every way, a normal comet from another star system. This makes it the perfect control case. When compared side by side with Oumuamua, the differences are staggering. Borisov came from an old, mature star system consistent with what we expect for a naturally formed object. Its motion and behavior fit neatly into the framework of classical astronomy. But Oumuamua? It defied every rule. No outgassing, no tail, anomalous acceleration, unnatural shape, a trajectory that seems intentional. UCLA astronomer David Jewett put it bluntly: Borisov is a comet. Oumuamua is a puzzle. Even their shapes were wildly different. Borisov had a standard spherical nucleus. Oumuamua was long and thin, 10 times longer than it was wide, a ratio that's never been seen before in any natural space object. What was its purpose? If we seriously entertain the idea that Oumuamua was artificial, we must ask the next obvious and chilling question. What was its purpose? Its behavior wasn't random. It moved with precision. It approached Earth closer than any other inner planet. It accelerated without propulsion, and it left without making a sound. All signs point to intentionality, the kind we associate with design. What was it doing here? One possibility is that Oumuamua was a probe, a kind of cosmic observer, sent to gather data about planetary systems like ours. This idea aligns with how we build our own spacecraft. When NASA sends a probe to Saturn or Jupiter, it's programmed to pass close to its target, gather data, and then move on. That's exactly what Oumuamua did, just on a far grander scale. Another theory? Oumuamua could be a data buoy, a passive device meant to drift through space for millions of years, recording data until a more advanced ship retrieves it. In that case, it might be part of a galactic network, with thousands of these silent messengers mapping the stars. The mystery isn't over, Torts. Oumuamua came and went in silence, but it left behind a thunderclap of questions. Was it natural, artificial, or something in between? We may never know for sure, but one thing is certain: it wasn't ordinary. As more objects like it begin to appear, the line between science fiction and science fact is blurring fast. If you're as fascinated by these cosmic mysteries as we are, subscribe and turn on notifications. Drop a comment below. What do you think Oumuamua really was? A rock? A probe? Or a visitor? This is only the beginning. Stay curious.